started. Alright, so we're going to talk about loops, which we know about in Scratch already. We're just going to learn their Python equivalents, and then we're going to talk about a way to store a bunch of things, lists, but I think we're going to do it in reverse order. So let us begin. Before any of that, though, oh, by the way, loops, right? You have code and you're coming around back on it. It's repeating itself, looping around. That's where we're going. But before we get there, I want to talk about how you can make mistakes in Python, because I think that you've tried this already, right? You've made some incorrect Python code, and it's kind of yelled at you. It's made some red text, and it's a little scary. So let's talk about errors in Python, because it's possible to speak Python incorrectly. There's two main kinds, all right? The first kind is probably the one that you've experienced the most. It's the one that jumps out at you. They're called runtime errors, right? Run is important. A runtime error is something that went so horribly wrong, Python has no clue what to do. It is unrecoverable. It happens as your program's running. Nobody could have expected it, and then your program just has to give up. Like Python's like, I'm done. I cannot recover from this, so it stops itself. All right. So a good example of a runtime error is like division by zero. Division by zero is undefined, and so Python has no clue what to give back as an answer because there is no answer. So let me just make a program that quickly divides by zero, and I'll show that to you. I'm going to open up idle and make a new file once it loads. Let's see, what lecture are we, by the way? This is lecture 19. All right. So I'll make a new file, and I'll save it in a lecture 19 folder. This will be called runtime error.py. All right, so here's a program that divides by zero. It's a bad idea. All right, so it's going to be like, let's make it subtly divide by zero. That'll make it more fun. Like, sure, I could just be like print 42 divided by zero, but then you might be like, why couldn't Python just figure that out? Let me make it even more subtle. Let's be like n equals getting an input from the user. Enter a number. And then let's make it an int. Let's say that we're getting an int from the user, so we'll convert it. So now n is a box that holds an integer variable. And let's print the result of dividing 42 by whatever the user gave me. Okay, because sometimes it's okay, sometimes it's not. 42 divided by n is colon, and then give the result. 42 divided by n. It'll just get replaced and put in there. Oh man, how fun is that? And then let's have another line, print hello or something, just for effect, so we can watch it work or not work. But do you see how subtle this is? If the user types like a normal number, this will work just fine. Python doesn't know what the user is going to type, so it has to let the program go through. It's like, yeah, okay, if you type 2 as your number, 42 divided by 2, that's 21. Cool, it prints hello, keeps going. But if we are an evil user, malicious, we can type 0 as our number. And that'll get stored into n, and then it tries to divide 42 by 0. And this is our runtime error, okay? This is like, it's usually very helpful. It's like on this line, line 2, here's what it was. There was a 0 division error, division by 0. Oh, okay, I should probably fix that, or watch out for it somehow, okay? And notice that it stopped the program. It's like, I don't know what to do at this point. I'm never going to print hello. I'm going to bail out, all right? Any questions about that? I'm sure we've seen this red text a lot by now, but it's just trying to be as helpful as possible because it is possible now to speak Python incorrectly. Scratch was a bit easier on us. Like you couldn't have messed up in Scratch like you can in Python. You got more power. More power here. Does that make no sense? That's a runtime error. There's plenty more where that came from. I'm sure you've found some more. But that's the easiest one that I could write up, I think. The other kind of error is very, very subtle, right? It's called a logic error. And another word for that, probably you've heard this one before, it's called a bug. A logic error is the same as bug. And that's just when your code, like you meant to do one thing, but it ends up doing something completely different. Like the program runs to completion, it's fine, it's happy, it gives you back an answer, but it's just the wrong answer. That's what it means to have a bug, all right? And I'm sure you've experienced that too. So I don't need to make a program for this, but here's like a silly example of a bug. Like you store you store 42 in the I variable, and then you're like, I'll make a variable called I plus 2, and I'm going to put the results of I plus 1 in it. You see that's a logic error? Your program is going to be fine. It's going to compute some answer, and it's just probably going to be wrong because you made a variable called I plus 2, and you're probably supposed to store 44 in it, but you put 43. You see that? So that's a bug. That's a logic error. It's much harder to track down because it's not going to stop the program and tell you that something went wrong. It's just you have to figure it out some way or another. It's a little bit more difficult. Any questions about the errors that you can have in Python? So you can either speak it so wrong it stops itself, with either a syntax error or this runtime error thing, or you could be a little bit off in your calculations, and that's a logic error. Say one thing, mean a different thing. That's how that works. All right. So if we're happy with that, let me talk to you about a concept called lists. They're a fun thing in Python. They're just a way to hold a bunch of stuff at once. We didn't actually have this power in Scratch. This is really nice. So let's say that you were making a video game, a 3D video game, or even a 2D video game. You need to store like where the enemies are on the screen. You need to store where the character is in the world that you've made. So you need to store 3 dimensions, right? 3-dimensional coordinates. Like I need to store that there is an enemy at this is x-axis 2, 3, 5. Okay, that's like 2, 3, and then go up 5. Right there. That's where an enemy is. That coordinate. All right. So you need a bunch of these all over your game, and right now, how do you keep track of this coordinate? All that we know how to do right now is just, okay, I better make a variable for the x coordinate, 2, make a variable for the y coordinate, 3, make a variable for the z coordinate, 5. And I have to like remember to pass them around all at once. If one of them changes, I have to like make sure that maybe the others need to change. That's a little unfortunate, right? So wouldn't it be nice, because this is like a point, we write it in math like this, right, with some parentheses, wouldn't it be nice to just keep the x, the y, the z, those coordinates all next to each other in one place with one name, okay? And that is what you can do in Python. You can say p, like make a point variable, and say square brackets, 2, 3, 5, and this creates a list. P is a thing with one name. It's a variable with one name that holds a bunch of stuff. It holds the list 2, 3, 5 all at once. Okay, that is beautiful. And the order matters, by the way, in lists. This kind of thing. This type is a list. Okay, so let me make some lists for you. They're just a way to hold on to a bunch of stuff at once because they're meant to go together. Like if you had a bunch of like coordinates. So I'll make a new file. Call it lists.py. And so let me make a p variable. 2, 3, 5. There it is. And now I can print p. It's all together. P is one name for all those things. Isn't that great? 2, 3, 5. Cool. And the type of p is a list. So print the type of p. It is a list. See that? It's a list of some other smaller types inside. Like it's a list of some ints inside of it. Okay. There's a concept of that kind of stuff. What else? That'll be the next slide. So let's just draw some more. So the order of lists matters. So for example, 1, 2, 3 in that order is not the same. It's not equal as far as Python is concerned to the list 2, 1, 3. Even though they have the same pieces, the same elements, they're just jumbled. So this is not the same as this. The order is important for lists. And so this one, we pronounce it as like, that's the list holding 1, 2, and 3 in that order. Okay, 1 is the first thing, 2 is the second thing, 3 is the third thing. Okay, and it's just one big thing. It's great. You can put it into a variable. Any questions about that so far? It's nice to have. Like if you want a million things from the user, you don't have to make a million different variable names. Just put them all in a single list. That's pretty cool. And then once you have all these things, it would be nice to extract the pieces. Like what's the first part? What's the second part? What's the third part? Maybe I want to extend it. You can do all that. All right. So here's how you use lists. All right. So the easiest way to make lists is to like give all the values in order. Just like say, all right, I want to list 1, 2, 3. But you can also build up lists. You can make them from scratch. You can let's see. there's a concept of an empty list, first of all. There's, let's see. I'll just use the REPL for this. Like, there's an empty list. That's fine. That's nothing. And then you can add two lists together with the plus operation. The plus operation works on lists, just like it works on ints and strings, strs, but it does something a little bit different. So if you add these two lists, it creates the bigger list. 1, 2, 3, 4. So that's pretty nice. Let me show you that. So the list 1, 2 plus the list 3, 4, that will create the list 1, 2, 3, 4. That's pretty cool. And then, like, you add the empty list to anything that does nothing, right? It's supposed to bring all the elements together, but there's nothing in the empty list to bring. Okay, so there's that. There's also a function called len. It gives you the size of the list, if you want to know that, like how many things are in my list right now, because maybe you just made it bigger. So how many things are in it now? You say len, and then you can give your list as a variable, or you just type it out if you want to. Like the len of this will give back 2. Okay, so len will tell you how big your list is. Len of 1, 2, or the list 1, 2. That is 2. Len of the empty list is 0, as you would expect. Okay, so you can do that. And so the length of our p list here, print the len of p, is 3. There's 3 things in it right now. Okay, any questions about any of that? Just building stuff up, yeah. The point of the empty list. It's if you wanted to start somewhere, if you wanted to accumulate a list. Let's say that you were getting a bunch of numbers from the user one by one. You'd start like a list at emptiness. And then you got one number from the user. You'd be like L equals L plus that number that you just got. And now L is a little bit bigger. And then you get another number from the user, like L equals L plus the list 55. And now L is a little bit bigger. So you can start with nothing because you have nothing, and then slowly put stuff in. That's the point. Yeah. Any other questions? All right. So yeah, that is that. Let's. I think the last thing I need to show you is how to get stuff out of a list, right? So everything in a list lives at things called indices. All right. So you can go to an index of a list and get out a piece of it. All right. So you can access each individual element using these things called indices. And so if you make a list called X, for example, that holds 5, 6, 7, here's how you talked about it. Like, here's X really. You think about it this way. You think of it as 3 different things that are separate. Here's the 5, here's the 6, here's the 7. You can get them out individually with indices. They start at 0. So the index of the 5, the very first thing in any list, is always index 0. It starts at 0, then it goes 1, then 2, and then so on and so forth if there's more stuff. So the index of this 5 is index 0. The index of the 6 is 1. The index of the 7 is 2. And then let me just draw this in green so that it pops out when you're reading this again. So that's index 0, index 1, index 2. That's how you get a piece of this list. Right? So if you want that first element, if you want to print the 5 or like do math with it, here's how you do it. You say X, let's see here. So yeah, it starts at 0. If you want the second thing, that means you want index 1. And then once you have decided on the index you'd like, you use this kind of syntax. Almost looks like you're making a little list. You say the name of the list, then you give a bracket, and then you give the index that you want. So 0, for example. And then you close the bracket. And this will result in, this will give back 5. That's how you say, I want the 0th thing in X. Okay, that'll give back 5. And then like X of 2 gives back 7. That's how you access pieces of your list. Okay. Let's see, how do I want to do that? Yeah, that makes sense. Any questions on that so far? That's just how you get a piece out. It's like if you want this thing, index 1, X of 1, X bracket 1 bracket. Okay. The indices also go in reverse order. So like if you want the last thing, you don't have to calculate it. There's always 2 indices for every spot in your list. So here's it going backwards. If you want this last index and you don't like want to figure out what the last index is, you can just be like X of -1. If you use negative indices, it starts going backwards. So this is X at index -1, this is index -2, this is index -3. All right, so there's always 2 options for whatever you want. So like another way to get out that 7 instead of x of 2 would be like x of negative 1. Negative 1. That would also give you back the 7. And then like x of negative 2 would give you back the 6. Could have done that one or index 1. Okay? So it also goes backwards. You always got 2 indices that work. Okay? So let me show you that in our built-up example here. So I've made the list P235. And so if I want the 2, I just want the 2 out, I can say print P of 0. P at index 0. That'll print the 2. There it goes, printing that 2. If I want to print the 5, print P at index 2, because it goes 0, 1, 2, right? That'll be the last thing. Here, index 5. And then if I want 3, it's either index 0, 1, or index negative 1, negative 2. Either one. Print P of index negative 2. That'll give me my 3. Okay. Does that make enough sense? So there's indices. You can access a piece of a list with an index, and you can also use that syntax to change a piece of your list. Like P of 0, you can put that on the left side of an assignment. You can be like, hey, P of 0, your index, index 0 of P, let's make it 7 now. So this also works. So use the same syntax to change an index. So that's totally going to work. It's going to be happy. And now if I print all of P, it's not 235 anymore because I made the index 0, 7. It's now 735. Okay? So that's possible. All right. Any questions about that? So those are your indices. Start at 0 or negative 1 from in reverse order. All right, if we're happy with that, please go to the Written Nice page and humor me for a second. I have a question for you, and please do attendance. I'll stop that too. Just a second. Okay, you can work on this as a group, but here's my question for you. Here's our list. It's called list capital L. It holds all these things in that order. Please write down 2 different ways to get that 5 out. Like I want this 5 right here. How could I get it out? What are 2 ways to get the 5 out of the list? Print this one way, print this other way. What would you put in these blanks? What are the 2 options for getting that 5 out? All right? So give that a try. Take a minute or 2, help each other. What number do indices start at always? Count up. That's one way. And then you have the way going backwards. So the last syntax is always something is negative, right? And go backwards when it's in document. There's actually many options here. You can also use let if you really wanted to do some weird calculations of like indices. But that's not necessary. Getting there. I'll give you another few seconds, or 30 seconds or so, let's say. And then what's next? All right, let's take a look at what we're thinking. Have we figured them out? 3, negative 4 seems to be the majority. All right. I think that's right. Let's figure this out together. Let's count. Boop. So thank you for that. Let's count these. So the indices always start, if you were going to go count up normally, it'd be like, it's going to start at 0. 0, 1, 2, aha. One index is 3 for the 5. That's one index, then it goes 4, 5, 6 if you're one of those. Otherwise, if you want to come in reverse order, it'd be like, this is index -1, this is index -2, -3. This is lovely. Other languages don't have this negative indices thing. -4, okay, -4 is the answer. And this would be -5, -6, -7. So your two options, your two normal looking options are print L of 3 or print L of -4. Okay, does that make enough sense? Any questions about that? Those are the two indices that you could use to get that 5. You could have been very fancy, I'm sure. You could have been like, could you have been? It could have been like L of 0 minus L of 4 or something to create 5. But this is the normal way, I would say. We're practicing indices here, right? Are we good to learn about loops now? All right, let's do it. So, loops, remember, it's the idea of having some code that can be rerun so that we don't have to like type it out a million times if we want it repeated a million times. So in Scratch, what did this look like? What did a loop look like? It was a thing, it was a block that could hold blocks. That was the body of our loop. And there was usually the coolest kind of loop, the most generic kind of loop, took a condition here. It's like, please repeat until this condition is met. But until then, run all this stuff that I put in here, all right? So just like for ifs and else's, in Python, this is going to be translated into some word right here. Then you put your condition after that, your Boolean valued pointy thing. Then you put a colon, and then you tab over. And then you put all the things that you would have put in here, right here. As many lines as you need, you tab over there. Okay, that's the goal. So that's what this is going to turn into. And so let's learn the words. All right, that's all we got to do. So you really do know this already. So first of all, the idea of a loop, it's just you repeat stuff. So a loop repeats a piece of code based on a condition usually. So you get to control how many times you repeat, like repeat 10 times, repeat 100 times in one way or another. So in Python, the standard kind of loop is called a while loop. So we're going to say the word while, that starts it, instead of like if or something. So while is going to be the name of our loop. And then it's called a while loop. It executes its body, the thing inside, all the lines that you put inside of it, as long as its condition is true. So it's a little bit backwards from the repeat until, because until was your stopping condition. A while loop takes what you want to be true and it runs the body as long as it's true. Stops when it's false. So here's kind of how a while loop is going to work. You're going to come into it and it's going to first check its condition. You're going to have some equivalent of a pointy thing in Scratch. You're going to have a condition here. And that's going to control this while loop thing. All right? As long as the condition evaluates to true, capital T, right? Then it will run all the lines of the body of the loop, all the things that you wanted to have executed as long as the condition gave back true. Go and run them now, please. That's what it's going to do. And then it's going to jump right back to the condition check. And as long as the condition's true, it will rerun that body. And that's how this while loop is going to work. And then the second the condition becomes false, though, that's when it's done. That's when it's like, all right, I'm happy. Once the condition becomes false, then it stops the loop. The loop is over, and it starts running whatever's below it, the rest of your code. Okay, so that's what it's going to execute as. That's the diagram. As long as this condition is true, it's going to run the body multiple times. And then the second the condition is false, it's done with the loop, and it starts running all of the code below. Okay, so it looks a whole lot like an if statement, to be honest. It's not too horrible, I hope. Let's see, where do I want to put all this? Yeah, so it's very similar to like if. Here's what the syntax looks like. You say while, and then you give your condition, your pointy thing, right? You give your thing that becomes true or false, put your condition there, and then you put a colon. And then as long as this condition is true, it's going to run the body of the loop, which goes right here. So you tab over idle does it for you. This is the body of the loop. Okay? This is the body of the while loop. That's the goal. Okay? So, yeah, it's just going to keep running the body as long as the condition is true. The second it becomes false, it like runs the code down. Alright? So, while cond is true, execute the body and keep repeating as long as that's true until it becomes false. Okay? So, I think the first kind of loop I showed you in Scratch was a forever loop, right? One that just ran forever. So, the way to make a forever loop in Python is to say while true is true, right? Because you can put a condition here, and it needs to, like, it's going to run the body as long as the condition becomes true. You just put true there. True is always true. So while true, that's never going to stop. Yeah? And there's your forever loop. This will always get run. Always gets executed. That'll work. Sometimes it's an error to have a loop that goes on forever, but I'll show you that anyway. If you ever run into a loop that is forever, that's infinite, if you want to stop it, if you meant to have it forever and you want to stop it, or you didn't mean it and you still want to stop it, it's Control-C in Python while it's running. If you got an infinite loop, Control-C stops your program. So let me show that to you. Here's a new file. So I'm going to make a forever loop. And I'll say while true, because I just got to put a condition there, something that becomes true or false. It's okay to put something that's already true or false. While true. And so this will repeat the body forever until the end of time. Print hello world. And so if that's my only line in the body, it's just going to say hello world until the end of time, until I unplug the computer. Does that make sense? And one important thing to notice is that, like, we're never going to get out of this loop. Print, we will never get here. Do you see that? Because this loop will continue until the end of time. It will never stop running the body and coming back to the condition check. It will never get to this line. Because this line is part of the body, and that's the end of the loop. This is the whole loop right here. This is just straight line code outside of it. We will never get to this line, because the loop will not stop. And let's see, let's call this forever loop.py. And if I run it, dun, dun, dun. Are you ready? Whee! There it goes. And so just printing hello world as fast as it possibly can. Once you're done, you want it to stop, you press Control-C. That stops the runaway program. And I think I let it run too long. It got unhappy. So sorry about that. I might have to restart idle. Because it's trying to remember all the lines that got output, and it just ran out of memory, I think. It was trying to be nice. It should have given up. Yeah, I'm going to stop this. Let's see, yeah. Well, that's another way to stop a runaway program. Just force quit it. Or unplug your computer. So let's see here. Where's idle? Where's Python? Oh, if you're not responding. There. Cool. Alright, so that's one way to stop it, too. Sorry about that. Let's go back to idle. And I'm going to press Control-C a whole lot sooner this time. Let's make these windows small again. So I'm just going to print hello world until the end of time. Control-C. Come on, come on. Control-C. I swear it's supposed to work. Oh, man. I think I was just not on the right window. I promise Control-C does work, though. Let's see. That's disgusting. Or maybe they changed it, honestly. It wasn't happy this time. Oh well. Take my word for it. If you can get there fast enough. If you have enough memory in your computer. Maybe it's a preference. Let's see. Let's go back. Options, configure. Can I just tell you to stop remembering lines? I guess not. Okay, never mind. That's the idea, though. So that's an infinite loop. It'll never stop. Let's make some other kinds of loops. Let's make loops that iterate and do stuff. Are you ready for that? So let's make a loop that like prints the numbers. Prints the numbers 1 to 10 in order. So instead of doing like this, right? Print 1, print 2. Let's make a loop that does this. Print 2, print 3. That's disgusting. We're better than that now. Okay? So let's make a loop that does this. We're going to print the numbers from 1 to 10 in order. And so let's use a variable, because we got to make a body that always works the same, runs the same code, but somehow prints 1 this time, 2 the next time. So we're going to use a variable to do that. We're going to start a variable I at 1, because that's the first number we want to print, right? So repeatedly, you print I. And so now it'll print the 1. And then you'll increment I. So that you're ready to make it print 2 next time. Increment I. You see that? So you print 1, make it 2, and then once you come back, now you're printing 2. See that? Increment it, make it 3. So that's how you're going to see a bunch of output. Like I is 1, print the 1, make it 2. Print the 2, make it 3. Print the 3, make it 4. Dot, 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 all the way. To print the 10, right? Print the 10, make it 11. And that's where we want to stop, because we don't want to see 11 in the output. Okay? So we want to print I as long as it's less than or equal to 10. You see that? That's the goal. So let's make a loop that does that. And I still swear that Control-C works. I just want to show it to you. Let's make a loop that just prints nothing at all. Infinite. Oh man. What could I do? It needs something for real in the body. I don't know, x equals 42. So this won't print anything. It'll just keep running forever. Control-C. There we go. So Control-C really does stop an infinite loop. It was just really unhappy. Or I wasn't on the right window, and I'm sorry. So that does work. But now let's count up. All right? Let's make a new file that counts from 1 to 10. And I'll save this and call this loops.py. Boop. So here's the goal. I want to print 1 to 10 on the screen in this style that we were talking about here. So repeatedly, while I is less than or equal to 10, print I and increment it. Does that make sense? That's going to be how we do it. So we got to start I somewhere. I starts at 1. And then while I is less than or equal to 10, do this. Colon. Print your current value of I, and then increment it. I equals I plus 1. So that's going to print 1 the first time, make I 2, come back to the condition, 2 is still less than or equal to 10, print it, make it 3, less than or equal to 10 still, make it 4, all the way to print 10, 10 is less than or equal to 10, print the 10, make it 11, and then try one last time. Oh, 11 is not less than or equal to 10, so we will stop. All right, so this is print and increment. All right, that's going to be the first one. Are there any questions about why that's going to print from 1 to 10? While I is less than or equal to 10, print it, increment it. Starting it at 1, though. So we've figured out some code that we could repeat that will print a different number each time. How cool is that? Well, that's that one. Can you kind of see how you would do it in reverse? Printing from 10 to 1. Similar style thing. It's just like start I at 10 this time. That's the first number we want to print. And then like print it and decrement it, right? Make it 9. And so there's a similar game that you could play, and let's play it. So you can be like print. Let me separate all this. And let's do another loop. So let's start I at 10. Going down to 1. So while something, print I and then decrement I. Right? I equals I minus 1. That's decrement. And now I have to worry about this condition. It can't be a less than. It can't be a less than. Let me try and show you why. It's like, if we were counting down, it's like 10, 9, 8, 7, all the way to 1. We print the 1. We want that. and then it decrements it one last time, makes it 0. And we want it to stop and not print the 0. So do you see how, like, 10 was our last number that we cared about, and we made it less than when we're counting up? We can't be like, while I is less than or equal to 0. That won't work, because 10 isn't even less than or equal to 0. You see that? It won't even start the loop. So this is just the wrong order. It's greater than. So as long as I is greater than 0 or greater than or equal to 1, then I want you to print it and decrement it. You see how once it becomes too small, it will pass this condition, and it won't work anymore. That's how we want it to work. That's the goal. So that's going to print from 10 down to 1. We had to flip that condition. Any questions about that? Fun little idea. Let's see here. So let's just spell that out. I think that's important. So let's do this on a different slide. So this was, instead of repeatedly print I and increment I, it was repeatedly to count down. Repeatedly, we wanted to print I and then decrement I, which makes sense. And so we want to be like, okay, I starts at 10, print the 10, decrement it to 9, print the 9, decrement it to 8, etc. All the way down to print the 1, right? Decrement the 1, make it 0, and we don't want to print the 0. We're done. So we want to keep printing. This is what you want to think, because we want to run the body that does this, which prints stuff. We want to keep printing. So you come up with your condition. Want to keep printing while I is greater than or equal to 1. So it's not less than anymore when you're counting down. Okay. You need something that's true at the start and then also becomes false at the end. Once it goes too far. Okay? That's the goal. And so that's why this is going to work and print from 10 to 1. You got to flip that condition. What was less than becomes greater than. Okay? You're good with that? What else could we do? Let's sum all the numbers. We have a way to go through 1 to 10 right now. Let's sum up all those numbers from 1 to 10. All right? So we have our I variable, and that's ranging from 1 to 10 properly right now. Steal our first loop. We're just going to need one more variable to keep track of that sum, right? We'll make like a variable called sum. And then we'll repeatedly do what to it? We're going to be, all right, repeatedly add I into sum. Sum starts at 0. Add I into sum. Now it's 1. Make I 2. That's the next number I want to sum up, right? Then bring the sum. Bring the 2, the new I value into sum. So sum is itself plus the 2. Now it's 3. See how that's going to work? Then make I 3. Now bring the 3 in. Sum that in. Now it's 6. See how that's going to work? And then eventually, like all the way to like add in the 10 one last time, and that makes, I think it's going to be 55 is the final answer of all the numbers between 1 and 10. And then you make I11, and you don't include that one in your sum because we're done. We wanted to stop there. But it has to get, for a split second, above what you want to stop the loop. That's the goal. Something needs to become false eventually. So you need to let it become 11. Just don't use that 11. Make it stop the loop. Okay? That's what's going on there. And so let's do that one. So it's mostly the same as, very, very similar to this first loop that prints from 1 to 10. Because this is, we've got an I variable ranging from 1 to 10. Let's just, instead of printing it, add it into the sum. Yeah. So like I starts at 1, sum starts at 0. And then I want to repeatedly, what do we got? While I is less than or equal to 10, like take my current I value and add it into sum. Add the current value of I. Let me try and make that go up for you guys. Add the current value of I into sum. Sum equals sum plus I. And then get the next number ready to be added in. And so as long as this is a valid number, it's less than or equal to 10, get that into the sum variable, please. And so then, by the end of this loop, once it stops, it will have added every number from 1 to 10 into the sum variable, And we could maybe go and look at that now. So sum now holds, once we get out of this loop, it now holds the correct sum of 1 plus 2 plus 3 plus all the way to 10. Yeah. And so we can inspect it by like printing it. The sum is colon sum. Boop. And yay, it did calculate 55 correctly. So you see how it's very similar to this first loop. It was already ranging. This loop was ranging I between 1 and 10. Let's just take advantage of that, and like instead of printing the I, add it into a sum variable. And by the end, we got the right answer. Any questions about that? So, a bunch of variations on the numbers from 1 to 10. Let's see. One thing that you're going to want to do very much, if you have a lot of numbers from the user, or you're reading a CSV file or something, you're doing data science, you're going to want to build up a list somehow, and then you want to go through that list. Like, you put a bunch of important numbers in a list somewhere, you can go through a list. Another word for going through is called iterate. I'll say that a lot. It just comes from the Latin word to go, right? So you can iterate through a list with a while loop. So if you have this list, you just want to go through all of the indices, right? That's how you get out each piece. It's like, this is index 0, always 1, 2, 3, 4. All you really need to figure out is like, what's the last index in this list? Because it could have been of size 1 million, right? Or size 42. What's the last index of my list? I don't want to go any higher than that because there's nothing after it. So the first index is always 0 for a list, as long as it's not empty. And then the last index is 4 for this particular list. And how do you know that? The question is, how do you figure that out? Here's the secret. You can use len. Len is your friend, because what does len give you? It gives you the size of the list. That's 5 elements, right? It'll give you back 5, because there's 5 things in this list. So len will give you back 5. And then if you just subtract 1 from that, that's always going to be the index of your last element. Isn't that great? So that's going to tell you when to stop. That's the last valid index for you. So now you can print a list very easily with a while loop. You just start, all right, I becomes the first index that I want to look at. It's always 0. And then while I is less than or equal to the last index I want to look at, I is less than or equal to len of x minus 1, then go and do something with I. It's a valid index. Go into the list at like x of I. You can do that. Do something with it. And then to get ready to go to the next index, just advance the I variable. I equals I plus 1. Does that make sense? That's how you can go through an entire list by keeping track of which index you're currently at. Going from left to right, maybe. Right? That's the goal. So, yeah, let's do that. Let me make a list for you. I'll call it capital L. Why not? Here's my capital L list. It holds 5, 6, 7, 8, 9, 1, and 13 for no good reason. So let's go through this list. Let's print everything out, for example. That's one thing that you might want to do. So I want to visit the first thing first and the last thing last. So I want to visit index 0 first, then index 1, then 2, then 3, all the way to the end. All right? So I equals 0. That's the first index I want to look at. 0 is always the first index of every list. And then while I is a valid index. So while I is less than or equal to the length of the list minus 1. Because that'll be the last index I ever want to look at. So remember that len of L minus 1 is the last index of every list L. Unless it's empty, then it like computes -1. That makes no sense. So you got to watch for empty lists, but we know we don't have an empty list right now. So there's that. And now I is a valid index. Let's use it. Do stuff with L of I. That's the idea. So print, we're just going to print it. Print the thing in index I in the list L. And then get ready, because you don't want to print the same index a million times. You want to eventually have I get bigger and get to the end of the list and stop. So keep going, increment I, to advance that place on the list that we're looking at. And this way, like the next index we look at, still smaller than the length minus 1. It's like index 1, print it. Index now 2, print it. Index 3, print it. As long as it's a valid index. And we have a condition to check that. So here it is, going through every weird thing in this list in order. 5, 6, 7, 8, 9, 1, 13. Any questions about that? Does that make enough sense? Could you go through a list in reverse order now? If you try that, you'd start at length of L minus 1, then go down to index 0. That's the last one you want to look at. Alright. Yeah, if we're happy with that, let's see. I think, yeah, are we ready to give a slightly more complicated example? Does this make enough sense for now? Alright, because I would like to go back to that idea of printing a bunch of random squares, right? We were doing that before. Let's make a program that draws 50 squares, not 5, 50 squares of random sizes and random colors. So this will help you with your programming assignment as well. We're going to use a loop this time. It's going to make it so much easier, right? We'll make an I variable, start at 1, make it go to 50. Just have the body be draw a single square, and then it will get repeated 50 times. That's great. Let's do that first. So I'm going to bring in the stuff that we did last time, copy and paste it. So this was randomsquares.py from before. I'm going to steal all this, copy and paste it into a new file, which I will call, call it randomsquares.py. I'll close the old one so that I don't accidentally change it. This is the new file for today. And so before, we didn't have loops. We didn't know about them. It was very ugly. We had to just repeat a bunch of code. This was the code that drew a single random square. Yeah, and we just repeated that 5 times. So let's get rid of the other repetitions. Unnecessary. And then I'm going to put all this in the body of a loop. All right, let's get rid of asking the user for a color. Well, let's keep it for now. That's fine. But do you see the easier way now? Like if I want to do this 50 times, I just need to make a loop that runs its body 50 times. So I can use I again. I won't print it. I'm just going to use it to keep track of how many times I'm doing something. So I starts at 1 while I is less than or equal to like 50, right? Because then it'll go from 1 to 50. That's 50 times. Do all this. Draw a single square. So it'll get repeated 50 times. And then, of course, remember to advance I so you're keeping count accurately. But that's really it. Like everything else is the same as before. If we run this, it will make 50 squares of whatever color we ask for. So I don't know. Feeling like red today. Boop. It's going to go and it's going to do this 50 times. So much easier than copying and pasting it 50 times, right? We get some cool abstract art out of the process. Are there any questions about that so far? Does that make enough sense? Like, once we have loops, this makes so much, this like saves us so much time, right? And this will keep going forever unless we change the speed of the turtle. If we say turtle.speed, we can say fastest. Draw very quickly, Mr. Turtle. That might actually help us get something done. Let's make, I don't know, blue squares. And so that's a bit faster. That's better. Are there any questions about how I did this? Drawn 50 squares randomly. Very cool and abstract. Let's see here. If we're happy with that, I'd like to go a little bit further, and that'll be it. So let's, instead of asking the user for a color, this will be really fun, let's pick a random color each time we draw a new random square. Here's how we'll do it. Here's the secret. We know how to make lists now, don't we? We can make a list of all the colors of the rainbow. Red, orange, yellow, green, blue, purple. We'll make a list of every color that we want to have as a possibility. And then every time we draw a square, every time we're about to draw a square, we're going to change the fill color to a random color in that list, and we'll pick it out by creating a random index. Does that make sense? We'll go to a random index of this list. We know how to do that. We know how to get a random number. An index is just a random number. Go into it, give me a color, set the color randomly. Won't that be great? So this will look really cool. This is very satisfying. So let me get rid of all this. Like, we're not going to ask the user for this color. We're going to set the fill color each time here. And so color to use, we're going to have to figure out, we're going to like set it to something else. It's going to be a new one each time, okay? And here's how we're going to get a new one each time. So remember random. and random.randint. That gets you a random number between some starting value and some ending value. We're going to use that to our advantage. So first we need a bunch of colors. Pick a random fill color. Colors list equals, just like you can have a list of numbers, you can have a list of strings. And that's what you give this fill color, right? So let's make a list of red, orange, yellow, whatever you like. You can put in this list, like yellow, green, blue, purple. And they gotta be strings. Blue, purple. There goes. There's my list. It's a bunch of colors. And I would like a random color. So I'm just going to go and pick a random index into this list. So, all right, that's just random.randint. And we know that the first index I want to potentially have as a choice is index 0. That's always the first one. So I want to get a random number between 0 and what? 0, 1, 2, 3, 4, 5, right? 0 and 5. Or if you didn't want to count, it's just between 0 and len colors minus 1. Does that make sense? Oops. This is going to be every valid index, a random number that has as a potential choice, every valid index. So that's your random index. And if you take your colors list and you go to that random index, whatever it was, index 2, it will pick out yellow and it will set the fill color to yellow. If the random index was 0, it will go to colors of 0, pick out red, and set the fill color to red. Does that make sense? Any questions about that? It'll do that every time, every 50 times, each time for 50 times. And then you draw your square with your begin fill and end fill at your random starting location and with your random side length. And look at how gorgeous this becomes. Every time it's picking a random color, and then a random spot and a random size. And so you have some very cool abstract art after all this. Any questions about that? How cool is that? So that's fun and surprising how far you can get, just like with some lists and some random numbers and the turtle library. So pretty. And you can make this bigger with that button too. So, yeah. Play around with that. You're going to get this code, of course. But I think that is all that I wanted to show you. If we're good, let's see. Yeah, I'll give you a new programming assignment, but let's worry about that on Wednesday. So that is all that I got for today. The rest of the time is yours to make pretty pictures and work on stuff that is already out.